Hey everybody, this is Dr. B and we are talking about Lab 4.1, the Solar Power Lab, and also discusses some other electricity use in your own home. All the websites you need to do this activity are at the top of the lab sheet here. You can notice there's the Part 1, Part 2, Part 3, and Part 4 websites. The Part 1 website is an actual solar recording right here. This is a solar recording website for a home in Minnesota, and we are looking at 3 days of data. We can go back and forth here. We can go back a little bit, look at some more data here on some sunnier days. You can tell how much power is generated here by the green. The green is power generated, the red is power used. We can see that the power generated most often is right around the middle of the day, which makes sense if you think about it, because the sun is shining highest in the sky and most easily shines on solar panels in the middle of the day. It's also the height of the sun is important because it gets up over buildings and trees and other things that may be shading the solar panels. It also has some of the strongest radiation that gets the solar panels to produce the most electricity. This is late in the day, so you can see the solar panels are starting to wind down for the day. And this is a live feed right here. And you can see it was a cloudy day because they go up and down based on whether the sun is covered by clouds or not. Let's go back to our lab sheet here for Lab 4.1. We did select the 3 days, and we just talked about what hours we produce the most power. Throughout the year, this answer can change depending on how high the sun is in the sky. In the summer, the sun is higher in the sky and there's also a longer day length. So if you have more hours the sun is shining, you can make more power. If the sun is higher in the sky, that is better for getting sun to your solar panels. Some of the solar windows change based on the time of the year. Solar window is how well the sun reaches the solar panels on your roof. Also, the tilt of your solar panels, if you're not tilting them specifically for particular times of year, you're just putting them on your roof and they're whatever your tilt the roof is, that tilt, that angle, is better for particular times of the year than others. The large red spikes on this system are power usage. So things like when the water heater comes on, there's an electric water heater in this system. There is when the microwave goes on, this is a microwave use. Starting the washing machine makes a big glob of power. You can see that in the morning, things like making the hot water heater run, turning on the bathroom fan, there's a heat lamp in the bathroom. All of those use a lot of power. Cooking dinner typically uses a lot of power. Things like humidifiers use power, air conditioners use a lot of power. So anything that's like a spike here, the refrigerator might have kicked in. Refrigerators use a lot of power, but they use it briefly. Don't leave the door open. Someone actually used one of these systems, these e-gauge systems, to call up a church and tell them they had a refrigerator door open, and they were actually correct because they saw they were using so much power, and because they were trying to refrigerate a whole room, the door was open. So all of these spikes here are high power usage. And there are things that use a lot of electricity. If you have an electric dryer, that'll use a lot. And again, like I said, humidifiers are also a culprit. When do you see the most power being used? This is actually something electrical companies think a lot about. If we look at the spikes, they're 6 p.m. and then again at 6 a.m. This is where people wake up and when they get home from work. And it's called, I believe it's called the camel spike because it's got 2 humps like a camel. So for residential electrical use, it tends to spike in the morning and spike when people start to get home from work. Most people aren't home during the day, so they tend to just have what's called phantom power or base power during the day, things that are plugged in all the time, like your refrigerator, your freezer, your TV, your computers, are always plugged in and using a little bit of energy, and so that's this kind of baseline when nobody's home. Look at the green box in the upper left-hand corner. How much money have we saved during the last month? Well, this particular month is mostly November. Let's change it to month here. Over the last 30 days, the system saved about $25. $60 of energy was used, $35 was purchased, and we saved $25 from the energy generated in this system. In different months, it is different. If you look over the last year, you can see over a year. If we take that $629 in a year and divide it per month, it averages about $50 a month. Obviously, it's much higher in the summer, and it's lower during the cloudier months. Also, we're in the northern hemisphere. Snow can fall on the panels, and it takes a couple days to melt off until some intense sunlight heats up the black surface of the panels and the snow slides off. So if we calculate based on the last 30 days, we've saved about $25. We have, if we take $25 and we multiply it times 12, that means we save $309 in 1 year. Really, it's more like $600 a year, but we're basing this information on 1 month that has poor solar generation. In 5 years, we'd save about $1,500, but really it's about double that if you include the summer months. So it's about $3,000 in 5 years. For part 2, we need to go to the website listed for part 2. So let's scroll to the top of the document. Let's click where it says Electric City Local. And we can put in our state here. We can put in our St. Paul Public Schools. Basically just put in St. Paul, unless you live somewhere else. And that's going to give us the electricity usage. We're going to want to scroll down here past all the ads. So here you can see the residential electricity rates in Minnesota, residential electricity consumption or usage in Minnesota, and the average monthly electrical bill in Minnesota. So for the average electricity bill, the usage, and the rate, you can go to that Part 2 website. If you're using the number for average in 7B above, what would be the average use for an entire year? Well, to calculate the entire year, go find the usage for a month and then multiply that by 12 months to get a year. So multiply 793 times 12 to get an average usage per year. we can take that number for an entire year and go into the Part 3 website here. We'll look at that in a minute, and figure out the equivalence. So if we use, say, 9,000 kilowatt hours per year, what does that mean in terms of how many barrels of oil we'd have to burn to get that energy, or how many pounds of coal? Let's go see how to figure that out. If we go to the EPA Greenhouse Gas Equivalencies Calculator, this is the Part 3 website listed at the top of the lab sheet. We can enter the data. We can calculate, oh, that's kilowatt hours per month, or kilowatt hours. And we can see that's pounds of coal burned here, or we can see barrels of oil consumed here. So here's pounds of coal, here's barrels of oil, and that will help you answer number 9. For number 10, the answers are all going to be different depending on your household. So for Part 4, you want to scroll up to the top. You want to grab the Part 4 website, and you want to look at, okay, so how many people live in your household? What type of home do you live in? Do you have Energy Star appliances? Those are very efficient, newer appliances. Do you use energy efficient light bulbs? Are you using the incandescent kind, or are you using the curlicue kind? Or maybe you have LED bulbs that might have kind of a star-shaped thing at the bottom instead of a wire. You can think about how many loads of laundry. This is all going to depend on you, and you may have to talk to some of the folks in charge of laundry and kitchen and transportation here, because there are questions about transportation, food, and then it gets to some analysis. You use your answers there to answer the questions for number 10 and 11. So once you're finished, make sure you turn this lab in for 4.1. Thank you so much. This is Dr. B signing out on the 4.1 lab.